Welcome to Math by McCaw. Today, our topic is fractions. Let's review a few details about notations first. These are the symbols we are using today for multiplication and division. And this is how we are going to represent the fractions. We may switch from one to the other. Finally, this is how we are going to read the fractions. For example, this fraction can be read as 3/7 or as 3/7. So far, we've worked with the counting numbers. They begin with 1 and stretch into the infinity, and then we've added 0 to get the natural numbers. Then we've decided to take the negative counterparts of these numbers into consideration and get the integers. They stretch to the infinity on both sides. Now, the things are about to get interested. So far, we've always worked with whole numbers like a whole 2 cakes, a whole minus $12.380 bank account. Now, we're going to divide those wholes and start to deal with fractions. Here, there are a few points we must be careful about. First of all, we are dividing the whole into equal pieces. Second, the number on the bottom, b, called denominator, tells us how many equal pieces we divide our whole into. And the number on the top, a, called the numerator, tells us how many pieces we select. We can divide our whole as many times as we like. We can take as many pieces as we like, even more than the number on the bottom. 47 halves, 108,952 31st, 582 fifths. But, don't forget, you can't divide by 0. And, lastly, here, both our numerator, a, and our denominator, b, are integers. Finally, let's call them with their proper names, rational numbers. And their set is represented as. Now, let's see them on the number line. As you may notice, they locate between the integers, our whole numbers. Let me show you a trick. Take any integer. I will take 5, for instance. 5 equals to 5 firsts. Now, 5 has become a rational number, 5 firsts. Okay, but what can be achieved by this? The result is that every integer can be turned into a rational number. Then every integer belongs to the set of rational numbers. The set of rational numbers contains the set of integers. Here, let's see the different types of fractions. First, proper fraction. For those, the top number, numerator, is less than the bottom number, denominator. Second, the improper fractions. Here, the top number, the numerator, is greater than the bottom number, the denominator. Third, the mixed fractions. This type of fractions contain both a whole number and a fractional part. Any improper fraction can be turned into a mixed fraction, and any mixed fraction can be turned into an improper fraction, too. Let me show you how to convert an improper fraction into a mixed fraction. Simply, begin with dividing our numerator a by our denominator b. Here, a, our numerator, becomes the dividend, b, our denominator, becomes the divisor. Let's denote the quotient by c and the remainder by d. Let's build up our mixed fraction step by step. First, the good news, the denominator, b, our bottom number, stays the same. Second, c, the quotient, becomes the whole part of our fraction, the number on the left outside the fraction. Third, d, the remainder, becomes our new numerator, the top number. Let's clarify it with an example. Take 438 fifteenths. As you see, the top number, our numerator, is greater than the bottom number, our denominator. And there is no whole part of this fraction, there is only the fractional part. So, this is an improper fraction. Let's convert into a mixed fraction. For that, we need to divide 438 by 15. Here, we get 29 as the quotient and 3 as the remainder. So, the whole part of our fraction becomes 29 and our new numerator is 3. As we've said, the denominator stays the same, 15. It is a relatively easy process. But why? Why are we dividing the numerator by the denominator? For example, take 438 fifteenths. Here, our denominator is 15. It means that we are dividing wholes into 15 equal pieces. We have 438 as our numerator. And it means that we take 438 pieces. One whole has 15 pieces. Since 438 is greater than 15, we have more than one whole. This is why we've divided 438 by 15, to learn how many wholes we've got and what's left. After our division, we found that the quotient is 29 and the remainder is 3. Then, we can write 438 equals to 29 times 15 and plus 3. And this means we have 29 wholes and additional 3 more pieces. With this knowledge, let's explore how to convert a mixed fraction into an improper fraction. Here, we have 7 wholes and extra 7 pieces. Since our denominator is 8, we understand that every whole is divided into 8 equal pieces. Since we have 7 wholes and every whole has 8 pieces, we have 7 times 8, 56 pieces, coming only from the whole part of our fraction. And, since our numerator is 7, we have extra 7 pieces, so we have 56 plus 7, 63 pieces in total. Now, let's look at the equivalent fractions. Some fractions may look different but gives us the same amount. As you may see in this example, we have 4 different looking fractions but they all indicates the same amount of the circle. If both the numerator and the denominator are multiplied by the same integer, the resulting fraction will be equivalent. But, how to distinguish them? What if we can't see it at first glance? Here comes the concept of simplifying a fraction. It is also called reducing the fraction. After simplifying the fraction, we get its simplest form or lowest term. In its simplest form, the numerator and the denominator of the fraction do not have a common factor. It means that only one can divide both the numerator and the denominator, and no other number can divide both of them without producing a remainder. Let's clarify this with an example. Take 36/24. Here, it is easy to recognize that this is not in its simplest form. Both 36 and 24 are even, so they can be divided by 2. 36 divided by 2 is 18. 24 divided by 2 is 12. And, in both cases, the remainder is 0. So we have 18/12. It is still easy to see that our fraction is still not simplified. Both 18 and 12 can be divided by 2, 18 divided by 2 is 9. 12 divided by 2 is 6. We get 9/6. Though 6 is even, 9 is odd. So, 2 does not divide them both now. We are done with dividing by 2. Now, we are moving on to the next prime number, 3. Do you remember the prime numbers? Let's remind them quickly. They are the numbers that can only be divided by 1 and themselves. No other number can divide them with remaining 0. The smallest and the only even prime number is 2. And they go on as 3, 5, 7, 11, 13, 17 etc. Except 2, there are no even prime numbers, so it is easy to eliminate all other even numbers as not prime. But, be careful, not all odd numbers are prime. For example, 9 can be divided by 3. So, it is not prime. As you notice, while we are simplifying a fraction or trying to find the greatest common divisor of two numbers, we generally check the prime numbers one by one if they divide our numbers. So, let's go back where we left. We simplified our fraction into 9/6. But it is not completely simplified yet. Both 9 and 6 can be divided by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. Since there is no prime number that can divide both 3 and 2, we are done. Its simplest form is 3/2. Here, we've ended up with both prime numbers for numerator and denominator. But it doesn't have to be the case all the time. For example, 48/25. Both the numerator and the denominator are not prime, but there is no number that can divide both of them other than 1. The divisors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. The divisors of 25 are 1, 5, 25. As you see, the only common element contained in both sets is 1. So, this fraction is in its simplest form. Here, we are actually finding the greatest common divisor of our numerator and denominator. And there is a schematic way to do that. For example, let's take 108 and 96. And, let's find there the greatest common divisor, GCD. 2 divides both 108 and 96. Again, 2 divides both 54 and 48. 2 divides only 24. Again, 2 divides only 12 and 6. Then, 3 divides both 27 and 3. 3 divides only 9 and 3. In this schema, we need to look for the numbers on the right that divide both of 108 and 96, 2, 2, 3. So, their greatest common divisor, GCB, is 12. And let's consider 108/96. To simplify this fraction, we need to divide both its numerator and denominator by 12, and we get 9/8. Again, as you see, neither 9 nor 8 is prime. But there is no number that divides both 9 and 8 except 1. They are called coprime. Let's organize the simplifying process. Let's take A over B. First, find the greatest common divisor of A and B, GCD of A and B. Second, divide both A and B by GCD of A and B. Third, take C as our new numerator and D as our new denominator, and we get C over D, the simplest form of A over B. And, lastly, let's go back to the concept of equivalent fractions. If the simplest form of two fractions is the same, they are called to be equivalent. For example, 90 over 120 and 33 over 44 are equivalent. The GCD of 90 and 120 is 30. The GCD of 33 and 44 is 11. So, the simplest form of 90 over 120 is 3 over 4. And the simplest form of 33 over 44 is also 3 over 4. Let's move on to a new topic, comparing and ordering fractions. First, let's begin with proper and improper fraction. We will examine this topic for mixed fractions later. When we want to compare fractions, the first thing we do is to look at their denominators, the bottom numbers. First, if the denominators are the same, check the numerators. Whichever has the greatest numerator, it has the greater value. For example, let's take 3/7 and 9/7. 9 is greater than 3, so 9 over 7 is greater than 3 over 7. It is easy to understand. We divide our wholes into 7 equal pieces, and first we take 3 pieces, and then we take 9 pieces. Of course, 9 pieces are greater. If their denominators are different, we need to find a common denominator. To do that, we need to find the least common multiple of their denominators. It is the same process with finding the greatest common divisor, but this time, we don't choose the numbers that divides both of them, we take all the numbers on the schema. For example, let's take 4 over 18 and 5 over 24. Let's find their least common multiple. 2 divides both 18 and 24. 2 divides only 12 and again only 6. 3 divides both 9 and 3. 3 divides only 3. In this case, their lowest common multiple is 72. And 72 divided by 18 is 4. 72 divided by 24 is 3. Then, we have to do the exact opposite of what we did to simplify the fractions. We need to multiply both numerator and denominator by the necessary number, in this case, 4 and 3, to make the denominator 72, the smallest common multiple. For 4 over 18, we need to expand it by 4. Our new numerator is 4 times 4, 16. And our new denominator is 4 times 18, 72. Then, our expanded fraction is 16 over 72. For 5 over 24, we need to expand it by 3. Our new numerator is 3 times 5, 15. And our new denominator is 3 times 24, 72. So, our expanded fraction is 15 over 72. Now we can compare 15 70-seconds and 16 70-seconds. Since 16 is greater than 15, we get 16 over 72 is greater than 15 over 72. So, 4 over 18 is greater than 5 over 24. Lastly, let's check it for mixed fractions. As we recall, a mixed fraction has a whole part and a fractional part, like C and A over B. When we compare mixed fractions, first we look at their whole parts. Like C, whichever has the greatest whole part is greater than the other. For example, let's compare 52 and 3 over 17 with 2 and 1008 over 105,609. Since 52 is greater than 2, the first fraction is greater. Why? Easy, because the value of any proper fraction is less than 1 and do not affect the result unless the whole parts are the same. Also, how many pieces we are dividing our whole into does not matter because, in any case, we are taking less pieces than a whole, 1, for a proper fraction. So, the fractional part may change the scale only if the whole parts are equal. Let's take 7 and 18 over 105, and 7 and 21 over 96. Since the whole parts of these fractions are the same, we need to check for the fractional parts. And, since the denominators of the fractional parts are different, we need to find their lowest common multiple and expand the fractions accordingly. The lowest common factor of 105 and 96 is 3,360. And 3,360 divided by 105 is 32. 3,360 divided by 96 is 35. In this case we need to expand the first fraction by 32 and the other by 35. 18 times 32 is 576 and 21 times 35 is 735. Hence, we get their fractional parts as 576 over 3,360 and 735 over 3,360, respectively. It is clear that the second fraction has the greater value. Now let's learn how to add and subtract fractions. First we need to examine the topic for proper and improper fractions. If the denominators of the fractions are the same, we just add or subtract the numbers in their numerators. Let's add 34 over 15 with 3 over 15. As you see, the denominators are the same. So, all we need to do is to add the numerators. 34 plus 3 equals to 37. And the denominator stays the same. We get 37 over 15 as the resulting fraction. Let's subtract 38 over 81 from 22 over 81. Again, since the denominators are the same, we don't touch them. We just subtract 38 from 22 and take it as our new numerator, which is minus 16. And the resulting fraction is minus 16 over 81. If the denominators are different, we need to find their lowest common multiple as the common denominator and expand the fractions accordingly. For example, what is the result of adding 12 over 25 with 3 over 20? First, we need to find the lowest common multiple of their denominators, and it is 100. 100 divided by 25 is 4 and 100 divided by 20 is 5. These are the numbers that we will expand our fractions by. Now, we expand our fractions by 4 and 5, respectively, and get 48 over 115 over 100. Now, we can add them as we've seen before. 48 plus 15 is 63 and the denominator, as always, stays the same. So, our resulting fraction is 63 over 100. Let's give another example for subtraction. Let's subtract 2 over 30 from 51 over 80. The lowest multiple of their denominators is 240. 240 divided by 80 is 3 and 240 divided by 30 is 8. Let's expand our fraction by 3 and we get 153 over 240 and 16 over 240. 153 minus 16 is 137 and the denominator stays the same. So, the resulting fraction is 137 over 240. Let's learn how to add mixed fractions. There are two methods we can use. First, we can add the whole parts and the fractional parts separately. For example, let's add 2 and 13 over 18 with 3 and 11 over 24. We add the whole parts together as 2 plus 3, 5. Since their denominators are different, we need to find their lowest common multiple, and it is 72. After expanding our fractions accordingly, we get 52 over 72 and 33 over 72. And, if we add them, the resulting fraction is 5 and 85 over 72. But, here, 85 over 72 is an improper fraction. We need to convert it into a mixed fraction and combine the whole parts. 85 over 72 is converted as 1 and 13 over 72. So, we've ended up a new whole number, 1. We need to add it to the existing whole part, 5. 1 plus 5 is 6 and 6 is our new whole part. The fractional part is 13 over 72, so, the resulting fraction is 6 and 13 over 72. As you see, we simply add the whole parts together after turning our improper fraction into a mixed fraction. For example, let's subtract 2 and 6 over 7 from 9 and 3 over 11. First, we subtract 2 from 9 and we get our whole part as 7. Then we subtract 6 over 7 from 3 over 11. After finding their common denominator, expanding the fractions accordingly, we end up subtracting 66 over 77 from 21 over 77. The result is minus 45 over 77. Here, the fractional part is negative but we have a positive whole part. So, we need to balance it by taking a whole from the whole part and adding it to the fractional part. We know that 1 equals to 77 over 77. So, subtracting 45 from 77, we get 28 as our new numerator. And, the resulting fraction is 6 and 28 over 77. If we want to add or subtract a proper or improper fraction to a mixed fraction, all we need to do is to take the whole part as 0. For example, let's add 21 and 8 over 43 with 10 over 3. 21 plus 0 is 21, our whole part. After taking necessary steps, 8 over 43 plus 10 over 3 is 454 over 129. As you see, the fractional part is an improper fraction, so, we need to convert it. To do that, we need to divide 454 by 129. The quotient, 3, gives us the whole part and the remainder, 67, gives us our new numerator. As always, the denominator stays the same. We add the whole parts, 21 plus 3 is 24. So, the resulting fraction is 24 and 67 over 129. Let's move on to the second method. In this method, we convert mixed fractions into improper fractions and add or subtract them accordingly. After completing the operation, we need to convert the resulting fraction back to a mixed fraction. So, since this is not necessary for addition or subtraction, this method is pointlessly prolonged. For example, let's subtract 2 and 2 over 3 from 5 and 1 over 2. After converting 5 and 1 over 2 into an improper fraction, we get 11 over 2. After converting 2 and 2 over 3, we get 8 over 3. After finding the common denominator and expanding the fractions accordingly, we get the result as 17 over 6. We need to convert it again, and the final result is 2 and 5 over 6. Now, we move on to multiplying fractions. This is the easiest operation on fractions. We just multiply the numerators together, and take the result as our new numerator, and multiply the denominators together, and take the result as our new numerator. Let's multiply 9 over 11 by minus 7 over 48. We just multiply the numerators. 9 times minus 7 is minus 63 and it is our new numerator. And, we multiply the denominators. 11 times 48 is 528. So, the resulting fraction is minus 63 over 528. Now, we can simplify our fraction by dividing both the numerator and the denominator by 3 and get minus 21 over 176. Here, there is an easy trick. You can actually simplify it while multiplying. While multiplying 9 over 11 by minus 7 over 48, we can divide both 9 and 48 by 3, their greatest common divisor. So, instead, we multiply 3 over 11 by minus 7 over 16 and get minus 21 over 176. There is one point that we need to be careful about: we must simplify numerator and denominator at the same time, and not the numerator with the other numerator, or the denominator with the other denominator. While multiplying 8 over 19 by 4 over 21, we cannot simplify 4 and 8. Both of them are on the top. To simplify them, one has to be on the top and the other has to be on the bottom. For example, multiply 8 over 19 by 5 over 24. Here, we can simplify 8 and 24 both by 8 and go on with the operation and get 5 over 57 as our resulting fraction. We can even simplify the given fractions while multiplying. For the first fraction, 14 over 21, both the numerator and denominator can be divided by 7. The simplified fraction equals to 2 over 3. And, if we multiply it with 2 over 9, we get 4 over 27 as our resulting fraction. If we want to multiply mixed fractions, first, we need to convert them into improper fractions and multiply them accordingly. If we convert 3 and 8 over 21 into an improper fraction, we get 71 over 21. And we can go on with multiplication, and while doing that, we may simplify our fractions, too. The result is 71 over 70. We may convert it into a mixed fraction, 1 and 1 over 70. Our last operation is division. Here, there are 2 steps. First, take the second fraction and flip it. Then, multiply them. Sounds easy enough. But, what is flipping a fraction? Well, it is called taking the reciprocal of the fraction, and we simply switch the numerator and denominator. For example, the reciprocal of 2 over 9 is 9 over 2. As you may guess, if a mixed fraction is given, we need to convert it and then flip it. For example, take 5 and 8 over 17. By converting it into an improper fraction, we get 93 over 17. And its flipped version is 17 over 93. As you see, we show the reciprocal of the fraction as minus 1 exponent of it. For example, let's divide 25 over 17 by minus 3 over 8. We need to flip minus 3 over 8 and we get minus 8 over 3. Now, all we need to do is to multiply these 2 fractions, multiply the numerators together, 25 times 8 is 200, and then, multiply the denominators together, 17 times 3 is minus 51. So, the result is 200 over 51. Cross multiplication. If we are given 2 fractions that are equal to each other, we can multiply one's numerator with the other's denominator and equalize these multiplications. AC equals to BD. Let's find A. Here, if we cross multiply, we find 6 times A equals to 27 times 24. And so, we get that A is 108. Congratulations! You've just reached the end of this topic. If you want to learn how to solve problems about fractions, please go to our next video. See you soon.